This is a WUFI Passive tutorial on setting up the foundation interface with an unheated basement condition in WUFI Passive. So when you're in WUFI Passive under the PH case branch, foundation interface, you have the ability to set up different ground connections within the software. So if I had a case where I had an unheated basement, I actually don't have to draw the unheated basement on geometry if I don't want to. I can just tell the software that this building is sitting on top of an unheated basement. So let's take a look at an example project that uses an unheated basement. In this case, in this kind of cutoff section here, you can see there's an insulated floor above an unheated basement, or an unconditioned space. The thermal boundary technically extends from the wall to below this floor. So that is what the 3D geometry in WUFI Passive would show. You could draw the unheated basement as an attached zone, but it's not required that you do that. So let's take a look at some of the entries we need. So the first entry here is the floor or ceiling area. So this is pretty standard for all the ground connections. We need to figure out what is this floor area. So you can do that by looking at takeoffs in your drawing, or you can simply come into your WUFI Passive model, select your ground piece, and grab the area. So in this case it's 1,151.36 square feet. So I'm going to go ahead and enter that here. Generally you can also detect this automatically from the geometry when you only have one ground condition. If you have more than one ground condition, using these drop downs is not the best option because it might grab multiple ground connections or multiple pieces that are connected to the ground and select that area rather than just a portion of that area. Okay, the second entry here is the U value of the ceiling to the unheated cellar. So what's the U value of this floor here? The ceiling of the basement or the floor of the building. So in this case, generally we would have built this floor out. This is part of the thermal boundary, so this is an assembly we'd build out in WUFI Passive. We're going to estimate what the U value of this might be. So it looks like we have, I believe, so if this is 10 inches, maybe 8 inches of EPS here, and maybe a 12-inch TJI. So let's say the TJI is filled with something that's R3.5 per inch. In that TJI, I can get about R42. That's not including framing, but we're estimating here. And then I have 8 inches of R4 per inch. So then total I have roughly R74 in this assembly. Again, this is just an estimate. This would be something you would figure out for your project. You'd actually build out the assembly and be able to grab the assembly in WUFI Passive and check out the U value here at the bottom. Or again, just detect it automatically. So we thought the R value of this is roughly R74. WUFI Passive asks us for the U value, so I'm going to take 1 over 74, which is 0.0135, and I'm going to enter that here. But again, you can detect it automatically. The next entry down is the floor slab perimeter. So this is another case where you could do a takeoff, or you can just pick your unheated basement component and find the perimeter here in the center, 136.67. Moving on, it asks us for the depth of the basement slab below grade, so let's jump back into our project here. So here we see a section, 2 subfloors, so we're at 0 here, or we're at grade here. And then below grade to the slab, we are at roughly 9 feet. You need to look at the whole building section though, so this is just a clip here where there's like a porch. So the entire basement wall is below grade, but it looks like a slope site. So on the right hand over here, it looks like the basement wall is actually exposed. So it's a walkout basement or condition like that. So when you have similar conditions, walkout basement or where grade varies throughout, what you do is you take an average of this depth below grade. So let's say on the left hand side, this condition, the basement slab is 9 feet below grade. But on the right hand side, maybe it's 3 feet below grade. So on average, let's come back to our WUFI model. On average, the depth of the slab below grade is 6 feet. We would, of course, look at all 4 walls, but if you have 3 feet here, 9 feet here, let's say we had 9 feet on another wall and 3 feet on another wall, that will give us the average of 6 feet. Okay. The next question is the height of the basement wall above grade. So this is kind of the inverse of that question, or the inverse of the depth of the basement slab below. So let's go back to our drawing here. So what is the height of this basement wall above grade? So the depth of the slab down here was 3 feet below grade. So the remaining height is roughly 6 feet, right? If we had 9 feet total here. So the height of this wall above grade is 0. So now on average, the height of our basement wall above grade is 3 feet. So you see now that the depth of the basement slab below grade and the height of the basement wall above grade now add up to that kind of total height of that basement wall, which we were calling 9 feet. Okay, so next we're asked to enter the U value of the basement wall. It looks like our basement wall and our basement slab are just concrete. So in this condition, you would use 1 as kind of a default, an R value or U value of 1. Looks like we had roughly 10 inches of concrete, which would actually add up to about R1. Concrete's roughly 0.1 R per inch, so times 10 would be about 1. And we're going to use the same condition for this slab. So the U value, oops, that would be here. So the U value of the basement slab here is also 1, just uninsulated concrete. The U value of the wall above ground or above grade. So we'd check our drawing. Potentially there could be additional insulation here and they cut it off at some point. In this case, there's not additional insulation. We have the same concrete wall the entire way. So the U value here is also 1. And lastly, it asks us for a basement volume. So this is something that you would need to calculate. We can do a rough estimate here based on the building we see in the 3D geometry. So if we take the ground piece again, we can get the area, 1151. And we can multiply by that ceiling height. So roughly 10,362 cubic feet. And then also in WUFI Passive, this will happen quite often. You'll see these little dot, dot, dot boxes. You can click in here and you could do this calculation. So 1151 times 9 feet will give us the volume there.